Hey, what's up you guys? This is the Kaggle Code Review Show and my name is Ilarian Garbasov. Today we'll do the competitive data science predict future sales Kaggle competition. Let's do it! Pow pow pow! First of all, let's talk a little about the competition. The competition name is the Predict Future Sales. It's a final project for how to win a data science competition Coursera course. So it's a regression problem. And let's have a look on the data. So you're provided with the daily historical sales data. The task is to forecast the total amount of products sold in every shop for the test set. Note that the list of the shops and products slightly changes every month. Creating a robust model that can handle such situation is part of the challenge. So it's a time series. Here is the file descriptions. So we've got the train data, the training set. It's a daily historical data. So you now understand that it's a time series. You have the test set and you need to forecast the sales for these shops and products for 1 month. So it's one step. You have a sample submission, supplemental information about the items, about the categories, and about the shops, the stores. Here are the data fields: ID, shop ID, item ID, and all the data about the sales. Okay, awesome. I found a notebook from the Karen Jakhar. It's a student at CU. What is CU? It's Chandigarh, India. So thank you, Karan, for your kernel. Okay, let's go. Let's get inside. And as usual, we would use Google Colab because it's good to calculate, easy to share, and you can use GPU hardware accelerator. Let's start. Let's first discuss what we're given and what we have to predict about our data set. So we have in our data set every date of items sold, number of every month of items sold, unique number of every shop, it's a shop ID, unique number of every item, it's an item ID, price of every item, number of items sold on a particular day. That's what we need to predict. So we have in our testing data the unique of number of shop ID and item ID pair, unique number of every shop ID and unique number of every item. Now what we have to predict. So we need to predict how many items of a type from each shop will be sold in a whole month. So our submission should have ID and item quantity on the month columns. Our approach will be simple. Our features will be number of items sold in months from a shop, including last month's data, because that will our labels. That will help our model learn to predict next sequence. So it's a time series and we need to predict only one next sequence. And for testing we'll use number of items sold in months from a shop excluding first month. Like this dimension of our data remains same. Our model will predict the next sequence and that will be our results. This is pretty simple approach, but it's good for start, good for the time series. Start. Please try something different if you want, but we'll do this. And as usual, we would use the Kaggle API. So we need to load the Kaggle JSON file and use the Kaggle API to download the data. So when we use the Kaggle competitions list, we can see that the name of the competition in the API is a competitive data science predict future sales, and we can download it with only one line. to our content path. And when the data is downloaded, we need to unzip our data sets, and then we can use it with the pandas, for example. First of all, we need to import libraries, so we would import NumPy for linear algebra, pandas for data processing, matplotlib for plotting, and we now can load the data with the pandas. So we would use a read CSV to load all the data sets. It's sales data, item categories, items, shops, sample submission, and the test dataset. And we can see the head of the sales data, how it looks like. So we've got the date block num is the number of months from 0, shop ID, item price, and item SNT day is a target that we need to predict. So we can see the head of the test dataset. It's item ID, shop ID, item ID, and the ID of the row. And the sample submission is just ID and ID of the item, ID, and our target. So we can see all the details of our datasets with the definition of the basic EDA function. So we would use the head, we would use info, describe, columns, data types, missing values, null values, and the shape of the data. And we can look to the all datasets with this defined function, and that's how it would look like. So for the one moment please. Oops. For the sales data, we've got top 5 records. Here it is. Remember that it's a time sequence. Okay. And it's a data frame with type of the columns objects, integer 64, float 64, and here you see the number of rows, the mean, standard deviation, minimum 25%, 50%, 75%, and the maximum, the name of the columns, the data types of the columns. We've got 0 missing values and null values, and the shape of the data is near 3 million and 6 columns. And for the test data, so it's the same format, and the shape of the test data is 200,000. 200,000, right? Okay, that's how our dataset looks like. So now we can transform the data from the sales data to date time, so we can easily manipulate with it. And after the transformation, the date column would look like this. And now we can manipulate and use it as an index. Now we will create a pivot table by going so we get our data in desired form. So we won't get total count value of an item over the whole month for a shop. That's why we made shop ID and item ID as our indices, and date block num or our column. So after we would transform our dataset as a pivot table, and after the transformation it would looks like this. So we've got shop ID as our index, item ID as our index, and date block num as our columns, and here you see the item SNT day as a sum. Yeah, aggregation function is a sum. And we can reset the indices so that data should be in a way we can easily manipulate. And after we are resetting the indices, it would look like this. So we've got date block num, shop ID, item ID, and the aggregation function with the target. Now we will merge our pivot table with the test data because we want to keep the data of items we have. Yeah. We would use the left join. In pandas it's the same as in SQL. And after that we've got none values, and we can fill it with zeros with fill an a in place equal true. And after we fill it, it now doesn't have null values, and test data and the train data is merged. So we'll drop shop ID and item ID because we don't need them. We're teaching our model how to generate the next sequence, and we need only indices. After dropping shop ID and item ID, it looks like this. You can see the dataset head. Now that train X train will keep all columns except the last one because we want to predict it, and the last column is our label. Okay, and for the test we keep all the columns except the first one to have the same shape for predicting after our model is fitted. And let's have a look on the shape. So that's how the train data shape, that is a train data shape, 200 examples, 33 features, 1. Okay, so it's a periods. And right now we can use Keras. We would import libraries required for our model. So from Keras we would import optimizers, we would import plot model, we would use sequential model, we would import convolutional 1D, max pooling 1D, and we would import layers, dense layers, LSTM, repeat vector, time distributed, flatten dropout, and from the metrics we would use mean squared error, and from the model selection we would import train test split. So let's define the model. The model we would start with LSTM. Our model would be sequential, so we can easily add new layers with add. And the first layer in our LSTM model, would be LSTM with 64 units, and the X-train input shape. Then we would use the dropout, and then we would use the dense layer with 1 neuron to predict our target. We would compile it with mean squared error loss, the Adam optimizer, and our metrics would be mean squared error. Here is a summary of our model. It's got 16,000 parameters and 17,000 parameters, sorry. And we can feed the model with X-train, our train dataset, our labels. The batch size would be 4,000 and 10 epochs. And with these parameters, we've got mean squared error on the epoch 10, 29. Okay, let's plot the loss. Sorry, we plot the loss curves for training, and you see the loss. It's and you see the loss. It's decreasing each epoch, so we avoid the learning problem. Okay, so now we can predict the submission. We can predict on the test data set, and with this model and these predictions we can submit the data to the leaderboard. We can submit our predictions at Kaggle.com. So that's how our submission would look like. It would look like the submission CSV, and the submission shape would be like this. Okay, but that's not all. We would try to use different deep learning models, and as the second model we would use perceptron. Just the same, we would our model would be sequential with one dense layer and 100 neurons. The activation would be ReLU, and input dimensions would be as our training data set. I would use as a second layer, we would use dropout, and the dense layer with 1 neuron for the prediction. Just the same, we would use mean squared error loss, Adam optimizer, and as you see, we've got ridiculously low number of parameters, so it's 3000, and the loss is decreasing each epoch, and on the epoch 10 we've got mean squared error equal 28, and we can plot the loss on each epoch, and you see that that it's decreasing, and we avoided the learning problem 2. So we can for the time series we can use not only LSTM, long short term memory, we can use perceptron, but also we can use convolutional neural networks, and that's how we would use it. We need to reshape the data. We would use, as usual, sequential type of model in Keras, and we would add the cond1t with the 64 filters, the kernel size 2, activation ReLU, and the X-train input shape. Then we would use max pooling, flatten. We would flatten the data. After we flatten the data, we can use the dense layer with 50 neurons and the ReLU activation. And after that, we can use dropout, or we can use dense layer for the prediction, and we would compile it with mean squared error and the Adam optimizer. Okay, and that's how what is the summary of our model for each layer, and the total parameters, trainable parameters, would be 51,000. That's how our model is fitting on each epoch, and at the end we've got ridiculously better results, 26 on epoch 10, and that's how our training process looks like. On the we can plot it, we can plot the history, and it's got better results than LSTM and perceptron model. And as the last model, we can combine two models. For time series forecasting, we can use CNNs and LSTMs together. We can divide our sequence for subsequences, we would reshape the data from samples, time steps, features into samples, subsequences, parts of sequences, time steps, and features. And this is how we reshape. And after the train set reshaping, the train set shape would be 200,000, 3, 11, and 1. Before the reshaping, it was 200,000, 33, and 1. And we will use a sequential model from Keras. We would add a time distributed convolutional layer with 64 filters. Then we would use a max pooling, flatten the result, use the LSTM with 50 cells, and dense for the prediction, and we would compile it with the same loss and the same optimizer, add the optimizer. And let's look what is the summary of the model. It got 75,000 parameters. So, and the result on the last epoch, on the epoch 10, would be better, even better. It's 25, and that is how we can plot the loss history on each epoch. And we can compare, plot all the models and compare it. So that was a time series competition. We've used different deep learning models. We can use for the time series not only the deep learning models, we can use ARIMA, we can use trees. But really the time series, I really love using deep learning because it's easy. You can better results. You can get better results with the deep learning models, and it's really easy to feed on when you got a lot of data. It's really easy to do. So at this competition we used different deep learning models. Hey folks, I really need your feedback. If you'd like the show, press the like button, subscribe, and tell me what competition do you want to review next. Thank you. Bye.